My name's Steve Goodhew from Plymouth University. I am logoless, mostly because the project I'm going to talk to you about, in fact, has only come through to us via an email in August. And just to echo some of the things that the past speakers have said about academic administration and the delays, I don't have any of those yet, so we're going freestyle. What I'm doing today is I'm talking about a project which, in fact, links four major players outside the lead, which is Plymouth, the Earth Building Association of the UK and Ireland, ESITC, which is a technical university in Caen, the main historic university in Caen, and a national park in France. And what I'm doing is I'm giving you sort of information out of context right away, because I'm going to tell the backstory now to the appropriate project. This particular project has been accepted, I think, for producing a series of cob mixes. And anybody who's not heard of cob, I'm going to explain that in a lot more detail in a second. An earth building system to be able to be used so that it will go through the current building regulations, which at the moment it doesn't. And it's one of the major barriers to an awful lot of natural materials and types of building techniques, both in the UK and across the world. And the usual elements of looking at low CO2, etc., and sharing the findings through networks, which is a typical EU type of method of operation. So very briefly, why am I standing here talking about sustainable materials, which is in fact the CobBauge project is about? Not wishing to tell people things that they don't already know, I will briefly go through these. For a construction material to be sustainable, they've got to meet a series of criteria. And these are kind of mine, but with a few others bolted on. This is not definitive, I hasten to add. Basically, they should come from diverse natural sources if they can. They don't have to, but that's certainly one of the criteria. If they're not natural, then something that has a low impact upon the environment. That's both through its process and normally because it's local. No harmful vapours, particles. Well, Kathy's presentation concerning air quality and the impact about one of the questions that came up from that echoes in this particular statement. Little energy used, production, transport and use, again, tends to flow back to a local type product. And long-lived, easy to maintain, and we were kind of coming up with a series of criteria which are almost impossible to meet. But there are some materials which do go a long way towards meeting them. It's a long-term, durable material. Equitable, socially fair means of being produced. And 6001, and looking at the sourcing and how people actually get hold of these particular types of materials, all gets bundled into this equality. And low waste, capable of being recycled and reused, less energy actually spent on processing of raw materials because of that, and salvage materials and building reuse and component reuse obviously are within that particular bundle. So bang, back to CobBauge again. There are different types of earth construction or building materials or methods, or the combination of the two, that are available. Three main ones. Blocks, of which adobe, clay lump, cob blocks, compressed earth blocks are all quite well known and used quite a bit across the world. Monolithic construction, of which rammed earth and cob, and infill. So a frame of which you would actually infill with the appropriate earth. And by earth, for all of these, we are talking about subsoil. We are not talking about topsoil. So let's focus down on cob, because CobBauge is all about cob. Of those three, it's a monolithic material. It's a vernacular material, particularly in the southwest of the UK. There are anywhere between 20,000 and 30,000 buildings, and The variants is, I'll tell you about it in just a second, of built from cob that are being used either for industrial, commercial or domestic usage within the southwest of England. So right up from Cornwall, Devon, Somerset, Dorset. As far as cob's concerned, it is a monolithic material, so it's produced in a bit like a layering technique, where the product is placed on a plinth, and that provides the protection from the weather. And the Devon adage is it always needs a good hat and a good pair of boots, i.e. it needs a good roof and it needs a good foundation to stop it being slowly but surely eroded by the weather. It's built in lifts of approximately 700 millimetres high, give or take. Each lift would dry, and by the time that's dried you would start and probably be finishing off the next lift, and slowly but surely you would produce a building. And thank you to Larry Keefe for those particular images. Any of the rest have been taken by myself. Where are they and what do they look like? Well, anybody who's been in and around Devon will know that the typical cottage with a thatched roof is the type of typology that you would see more or less all the way across that area of the county. And the reason why we're a little bit iffy about is it 20,000 or 30,000 is they're rendered. And because they're rendered, you're never absolutely sure what's behind the render. And some properties are up to 500 years old, made of earth, still going, still there, still inhabited and still being used. But there are new cob buildings which are being built. This was the first official cob building produced in for approximately 50 years, because as soon as Part L of the building regulations, and it was from the international, that's basically looking at thermal properties and performance of buildings within the UK, came through, they didn't meet that particular regulation. And this is a building in Ottery St Mary. It sold recently, I understand, for somewhere close to £1 million. It was under £1 million, but it was getting close to it. So they are desirable. And two of the most recent ones, this, unsurprisingly, just outside a place called Totnes. If you know Devon, you'll know Totnes. It is slightly alternative. But this isn't. This is up in North Devon, and this particular building was actually featured on the Grand Designs programme, and some people may actually recognise it from that particular programme. These two have gone through the regs. But the issue was considerable amounts of arm twisting had to take place, especially with local building control, to say this was a okay thing to do. The planners were fine. Planning permission wasn't a problem because there are elements within planning permission that say if you have got a large degree of sustainability built into a project, you have got less of an issue. But unfortunately, as far as building regs are concerned, regulations, well, it kind of says it on the tin, doesn't it? So there's a bit of an issue. That there is quite a pent-up demand, particularly in the southwest, because it's echoing a vernacular form, which people cannot physically build. And there are also existing cob buildings where things like structural alterations, re-rendering, elements about partial collapse and fire take place. And instantly you're into this. This was a really sad thing, as you can see. It's a pub, which mortified me, the fact that, and you can see the fire brigade is still dosing it down, so I was that concerned. I went and took a photograph almost immediately. It was fairly close by. This, in the end, this particular building was demolished. Not because it wasn't viable, it was because it didn't meet the regulations, and also the skill set which were around, available to be able to rebuild in the appropriate material, had virtually gone. There are cob builders out there, but they're not that many and they're extremely busy. So if you want one, you have to pay a lot of money. And when somebody says, well, look, we can rebuild it in concrete block or we can rebuild it in cob, here's the price difference, unsurprisingly, you're going to get the kind of response which kind of happened. I'm just going to briefly, and I apologise for this, Chris, I'm just going to quickly pull this one up. Mostly because I updated it.
No,
And you weren't to know. Don't worry.
Sorry,
It might, no, don't be sorry, it's my fault. Just briefly across the water, this is on the other side of the English Channel. This is placing it close to one of the French partners. This building is a Norman cob building. It's identical. The techniques are identical. The French have got a better position than us in that they have got more leeway within their regs, allegedly, and also they've got a better skill set as far as the number of people who are aware of the traditional materials and actually can build with them, but not a lot better. They're not vastly in front of us. This building is only scaffolding because you may just notice it's been re-roofed, so it's just having a new roof. The walls are fine, but the roof needs doing about every 25 years. So, and if you can closely see, cob over in Normandy actually has got no render. They don't perceive the need for it because they build, as far as the design is concerned, to throw the water away from the surface of the wall. Well, this is good news for the simple reason that we know how many of them are. They're not rendered, so it's as basic as that. You can count them and you can find out. And that's one of the reasons why we can put the estimates in Devon. Now, getting down to the nitty-gritty, CobBauge is trying to find these mixes, these high-performance thermal mixes that still maintain the structural compliance of what you need to get through Part A of the building regulations, but also satisfy Part L. And there's some funny things going on from previous measurements we've undertaken. You can see here cob, apologies for the numbers, density, thermal conductivity, these are the main bits to have a little look at. You can see cob and clay, and this is a sample taken from the US, almost identical as far as density, but quite a big difference as far as the thermal conductivity. There's an element of aggregate, which is within this, that isn't in the clay. That puts the density up, but then you add a fibre, which then brings the density back down again. So in which case, that's how you get that lower value. So you have the ability to take an earth material and reduce its thermal conductivity, but maintain its density, which is kind of odd, because normally one believes you add air to something to improve the thermal properties of that particular material. But the big issue is, even with that value for cob, to be able to get through the building regulations, and again, if you concentrate on that column and that column, the thickness, if we go up with cob, we start off with 400 mil, well let's face it, what's the thickness of most walls for highly insulated buildings nowadays in the UK? How thick? Right? About 400 mil. And you will get an awful lot better U value than 0.94, won't you? Considerably better. So you have to go big with cob. You have to go to 600 and then you get 0.66, 800, and you're still not at current regulation level. So the only way you can do it is to actually produce something that is huge. That's an 800 mil. It's not 500, that's a misprint. This is an extended doormat. There's the door. The doormat, it's massive. And that's what you're having to work with. Well, you tell somebody that you're going to nick a huge amount of the perimeter of the footprint of a building. That's not very sustainable, is it? How many can we squeeze on a hectare? Well, 3. So this is not good news. So what we've got to do is we've got to be able to get a more thermally efficient cob material if anybody is going to get through the regulations and anything is going to be built. There are other solutions that you can put in place. This is a building built that's been designed by the architect for the national park that I mentioned earlier, and it's got rammed earth on the bottom, and it's got straw bale on the top. This is in the national park over there. So there are various solutions, but the thing is, cob's the vernacular form. Cob's been used and is true to the area, and they're still standing for after centuries. So there is a driver to be able to use them. Other ways you can do it is to try and do a mix and match. For instance, this I think is personally a little bit bonkers, but it is a personal viewpoint, that you have cob and then triple low emissivity glazing in it, which is completely sealed. You please note, I cannot see, and there aren't, I can assure you, any trickle vents in that. That's trying to get cob to passive standards. Okay, passive has its place, it really does, and it's a very good solution in certain areas, but to try and mix and match a breathable solution with a non-breathable solution is actually asking for trouble in certain areas. You may be able to do it with MHVR and other systems which are really appropriate, but it's going to be hard. The other thing is, I don't know if you saw the end of the Grand Designs program, but the person that built the building was putting polystyrene on the outside of the cob. Again, this is not me shooting polystyrene. Polystyrene has its place. It does. It's a blinking good material in certain areas, but for a material which is a hygroscopic material, highly hygroscopic, which most clays are, putting polystyrene on the outside of it is stopping the in and out as far as the moisture flow is concerned. So we've been looking at those particular properties using a moisture probe we developed for straw bale, looking at straw bale buildings, and we put those in the cob building. And watch this space, we're going to find out what happens to that. And there are standards which are coming through. People are getting aware of these. The Americans, ASTM, New Zealand standards, European standards from Germany, looking at earth buildings. And please note, 2016, you know, we're not talking about a long way away. We're talking about very current interest. But you can see that to try and get those standards without having an appropriate solution is a very difficult task. So our project is to try and produce those from 2 local mixes in the UK and from 2 local mixes in France. And as part of the presentation, I'll pass these across. There's some further reading. And some of the elements, yeah, I know, I put a plug in, I'm sorry. I'm very sorry. But some of the elements, particularly about the thermal side and the material side, are in sustainable construction processes. Thank you for your time.
Thank you.